Welcome to aspirants. Today we are going to discuss a very important topic which is part of GS3 syllabus and also because it is making headlines all over the world. The robustness with which our space sector has increased over the decades, India is moving ahead and becoming a space power. Okay, so let us discuss this from its humble origin and the organization. Well, no space activity can be started or any topic on space can be started without mentioning Dr. Vikram Sarabhai, who was the chief architect of our space program. And because of his contribution, the first Indian National Committee for Space and Research was formed in 1962. Now that became the center of all space activities in India, and later on it fructified into what we today called as ISRO. So let's begin with the journey. And later on, then he established Thumba Equatorial Rocket Launching System in 1963. Both of these institutions became pioneer in establishing the space program in India. And we can see today now is that India is emerging as a very important player in the space sector. You can see here the rocket boys. So I have mentioned two rocket boys here, Dr. Vikram Sarabhai and Dr. Satish Dhawan. Because of their contribution, the ISRO or the space sector in India is what it is today. The Space Science and Technology Center or the Vikram Bharat Sarabhai Space Center that we call now in Trivandrum became the hub for sounding rockets or solid propellants. The Experimental Satellite Communication Earth Station or the Space Application Center in Ahmedabad, which became the Payload and Electronics Development Center. And here we can see that most of the application part, like the Bhuvan portal or the geospatial technology, all these are implemented here. Finally, ISRO was born in 1969, where INCOSPAR, which we discussed earlier, was replaced and formerly known as the Indian Space Research Organization. Today, the total workforce is 18,000, and many of the centers are focusing on specific domains, just like the Space Application Center, okay, the Vikram Sarabhai Space Center. All these have very specialized centers which are working on a very specific technologies. Now, in 1972, as we move ahead, the Department of Space was formed, and Dr. Satish Dhawan took over the reins of these organizations and all the space activities in India. Okay, now we come to the years of experiments. Once the organization were established and started performing their functions, the years of decade of learning started. This was the year of experiments with the experimental satellites such as the Aryabhatta, which was also India's first indigenous satellite, was launched in 1975 with the help of Soviet Union. Later on, Bhaskara 1 and Bhaskara 2, the experimental Earth observation satellites, were launched again with the help of the foreign powers. Later on, what we see is again another experiment was done on the Ariane, the Apple, which is called the Ariane passenger payload experiment, which was the communication satellite. Again, it was an experimental satellite was launched. This was on the European space. It was launched through the European spacecraft called the Ariane, which is even still we are using it for launching very heavyweight satellites like for the GSAT. The interstate space cooperation shown in launching these satellites was very eminent, and we can also see that since the 1970s itself, we started collaborating with many foreign countries like Russia, the Europeans like France, and we are still moving ahead with them. And now we have also collaborated a lot with USA. During that time, and again, another very important program, the Satellite Instructional Television Experiment. This satellite telecommunication experimental projects was started, which led to INSAT satellites, the Indian national satellites, that we use each and every day functions that we perform on our television sets or for communication. These were the satellites. These are satellites that are helping us. Now the experiment started bearing some fruits. So in the launch vehicle, you can see that in 1980s, 18 July 1980, being the exact date, SLV-3, the first indigenous satellite launch vehicle, was had kicked off, which was a four-stage solid propellant, which could take the payload of 40 kgs into lower Earth orbit. Now, based on this, the augmented satellite launch vehicle, which was an improvement on the SLV, was launched. Both of these experiments then gave confidence to reach the PSLV, the Polar Satellite Launch Vehicle, which is the most reliable workhorse for India, and it was commissioned again in 1980s. The INSAT 1B multi-purpose satellite was launched again in 1980s, which became brought in a revolution in the telecommunication sector. That is when we started gaining connectivity in remote areas. Television was started, which led to the boom in what we call satellite TV watching and broadcasting. And we know how Mahabharata, yeah, Ramayan became very famous, and Doordarshan became very famous since then on, and even for weather forecasting. And since the experiments were also carried out in other domains, the Indian Remote Sensing Satellite IRS-1A was launched in 1988. Later on, INSAT-2 was launched. Okay, coordination of INSAT Coordination Committee and the Natural Resource Management Committee was also done so that these satellites can be linked to ground level problems. So, for example, crop yielding, groundwater management, mineral processing, forestry, urban sprawl, wasteland, fisheries, all such things can be managed from the ground and from the satellite. So, for that, the coordination was established between INSAT, that is ISRO, and the National Natural Resource Management Systems. Now we come to the post LPG era. In post LPG era, we had more advanced satellites which were used for cartography, resource survey, ocean and atmospheric application. Again, we're coming back to INSAT. We have lots of INSAT satellites that have been launched that again focus on telecommunication, television, radio, satellite news gathering, societal applications, weather forecasting, disaster management. The societal aspect was very important or a cornerstone for establishing the space program. So that is why we see that it is being used in surveys. It is being used now in security also, security of women, security of our national security. We have so many satellites now. The next, which are one of the heaviest satellites in India, is a GSAT 1, GSAT, and GSAT 11, 29, and 19 are high throughput satellites. That is, they can manage a lot of traffic, to and fro traffic from them. They support the Digital India mission to connect the Gram Panchayats and also bringing connectivity and bridge the digital divide between Northeast and Jammu and Kashmir. Now we see the domination of our space program begins since 1990s. The 1994 most reliable workhorse of ISRO that started launching our satellites on our own, and we till now had around 50 successful internal missions, like the indigenous missions, and it has launched more than 200 foreign satellites also. Apart from that, the world record was also established at that time of launching 104 satellites in 2017. And the ASLV, the PSLV helped us master the liquid and solid propellant technologies and then led to the cryogenics, which gave birth to GSLV. The GSLV launch vehicle D5 was successfully tested in 2014 with the cryogenic upper stage. Cryogenic upper stage is the one where the fuel is used at very low temperature. It is liquid hydrogen and oxygen, which are burnt at very low temperature to gain maximum thrust. Later on, we can see that GSLV Mark III came into being, which is the higher version of GSLV, and it can carry to 4-ton payload into GTO orbit. This also launched some important experimental platforms like the Crew Module Atmospheric Re-entry Experiment, which is used by the crew to enter back into the atmosphere. So this was tested and this was recovered in Bay of Bengal. The Chandrayaan 2 Earth, it also launched Chandrayaan 2 into Earth parking orbit. Now we come to the space capsule recovery experiment in 2017. It was there in orbit for 12 days, and it did an experiment on the reusable launch vehicle technology. Now we just saw how the Falcon 9 or SpaceX also used the reusable launch vehicle technology. So we also started that in 2007. Now the space science missions like the Chandrayaan 1 was launched in 2008, which had a moon impact probe, and it successfully identified water molecules on moon. Then we took a look at the Mars, where mission orbiter Mars MOM was launched in 2013, which reached in 2014, and we became the first country to do it successfully in the first attempt. Otherwise, we were the fourth country to reach Mars. Chandrayaan 2 was also launched in 2019. However, the rover was destroyed, but still 90% of this mission, which is based on the rover, uh, that is, I mean, the satellite that is launched there, that is still being carried out, carrying a lot of experiments, and it is sending a lot of valuable data back to us. Then, then we moved ahead. Now you can see we are moving slowly. We are moving into advanced level. So Astrosat 2000 it was launched in 2015, which is studying the astronomical objects. It is trying to gauge through our solar system and beyond to identify different planets, stars, and study their properties using the X-ray, UAV, and political bands. Now, the very important part is the navigation. India is one of the few countries which has its own navigation system called the NAVIC, which is very highly accurate and it has been approved by the 3GPP. So soon we know that we are hearing this in news. We will have smartphones and devices which will be NAVIC enabled. Again, we have another Gagan's navigation program, which uses the GPS technology, okay, and then provides applications such as civil aviation and and air traffic management. From here on, we take a leap of faith in 2018 and announced Gaganyaan program, which will be a new age human exploration which demonstrates space flight in low Earth orbit and for a defined duration and space recovery. Now, this will be a benchmark for India as this program will enable us for future human exploration into the space since US and other European countries and China are racing ahead and they are establishing human presence not just in uh, within the within our space but other terrestrial planets such as Mars also, and they're trying to establish colonies. So this is very important for our future, for which we had also established a human space flight center. This will be a lead center for Gaganyaan and affordable human flights. So you can see in all these experiments, affordability is the cornerstone again for ISRO because despite having so low budget, it could do so many things. We also see that other technologies apart from this, the pad abort test in 2018 for crew escape system was also tested. So these are used for contingency whenever there is an emergency. This technology is used to safely evacuate the crew. And for human resource development, the Indian Institute of Space Technology was established in Tiruvananthapuram. And for enhancing our security, we saw how anti-satellite technology was also tested. Now we see that since this all was being done only by ISRO independently, with very little involvement of the private sector. So the government during COVID has announced a lot of reforms. Seeing the success of SpaceX, that we have we want an evolution in the space ecosystem to include the private sector, for which in space the International Space Promotion and Authorization Center has been established, which promotes which will promote and handhold the private sector, diffuse space technology like we have done in case of lithium ion batteries, enhance the space sector further so that more experimental satellites can be created and more research can be done through private sector involvement, because they will also bring in lot of funds and specialization and efficiency into the sector to further give a boost to it. Again, a very important national New Space India Limited was formulated, which is the private public sector undertaking of government of India, that will also allow a private sector to engage directly with the government and establish new I mean they can use the facilities and also do their own experiments within the facilities and work closer with the government and the private sector. Also from supply chain driven, where we had limited supply of launch vehicles only based on whatever India needed. Now it will be demand driven. Now the private sector can also demand special launches from ISRO to put their own satellites into orbit. The future. Now, when you look at the future, we are advancing in research and development. More heavier and efficient satellites are being built. We are also talking about Chandrayaan 3, that is future launch to be launched in future. Aditya L1 mission for Sun, then the mission to Venus, and obviously Gaganyaan. Now, if you see the focus of space program, initially the main focus has been the development and utilization of space technology for overall development of the country, and for which the society was the cornerstone around which all the space programs evolved. But now we see major shift in that, because we have tested, tried, failed, and produced very critical technologies. Now we're seeing a major shift where we are going for new age human exploration. We are also enhancing our security. We are involving the private sector more and also focusing on research and development even more. The transfer of technology is also very important. And we are also now focusing on profits and revenue generation. So this is all about this topic. Thank you.